on, and we want to look at solubility in water. So let's just revisit this again. Water, we know, is polar. You can imagine that water is, the reason we call it polar again is you can almost think of it as like little mini magnets. Normally when we talk about magnets, we have like the north and south pole of the magnets. Well, a polar compound is a molecule that has sort of a positive and negative side to it. So it's like it's a little mini magnet. So if we were to look at, if you were to think of these little mini magnets, they're going to be attracted to other things that have sort of these magnetic attractions to them. So if you have an ionic compound, like salt is ionic, salt has these positive and negative charges that could be attracted to the partial positives and partial negatives of water. So even though these are only partials, there is some sort of attraction between these. If I were to look at a different ionic compound, or sorry, a different, I should say that's ionic, so it should be very soluble in water. If we look at a different polar compound, for instance, let's go with HCl, although I'm kind of lying a bit. Actually, HCl will fully ionize in water, but let's pretend for a moment that it doesn't. HCl, which will have these partial positives and partial negatives, will also be attracted to the partial positives and partial negatives of water. So then this can mix up with the water molecules, and this is also soluble. However, if we have something like oxygen, it's going to be less soluble in water because it just doesn't have the positive and negatively charged ends to interact with. One of the ways I like to think of this is if you imagine you have wooden blocks floating in the air where there's no charges hanging around. And then you have these other sort of magnets floating around in the air. Well, you might shake all of these up and they'll be separate for a moment, but eventually what's going to happen is that all those magnets are going to get attracted to each other, and so they're going to just group up together, and then all these other uncharged, non-magnetic wooden blocks are just going to end up together. So this is why when you guys make salad dressing, like the oil and water separates, because the water is like these magnets that will eventually attract to each other, and the oil is like these wooden blocks that just kind of get left behind. Finally, we have to talk about conductivity. So again, it all goes back to whether these particles have charges or not. Electricity is made of electrons, and that's why they were called electrons once they discovered that, or at least conceived that electricity was made of electrons. And electrons are little tiny negatively charged particles. Well, what are negatively charged particles attracted to? They are attracted to positive particles. So if there are no positive particles to pick up and pass on electrons, then there's going to be no conductivity. Okay, so you have to think of it this way. That conductivity is not about passing through. People like to think of electricity as passing through something. You have to think of an actual atom has to, in essence, kind of like catch and pass an electron on to another atom. So if we go back to salt, imagine salt, and it has to be dissolved in water. if we have salt that's floating around, you can clearly see that salt has positive cations and negative anions. So if I were to toss a little electron in there, for instance, let's say I've got a bridge of my conductivity tester, well, this electron can be sort of attracted to that sodium ion, and if it's dissolved in water and things can move around, then that sodium ion can pass it on to another sodium ion, which could pass it to the other part of the conductivity tester. And so then you'd see your little red or green light turn on, bing, and then you know that it conducts electricity. When we have water, just plain old water, I mean, people do know that water does conduct electricity, though not quite as well as other substances, but it's because, again, there's this partial positive that can attract that electron, though not as strongly as a full positive charge of an ionic compound, or even if we have a metal which is completely made of cations, which is why metals are conductive. But if we were to look at oxygen by itself, notice how there are no positive charges here. So that electron kind of just stops. There's nothing to pick that electron up. So if you have your little conductivity tester, you notice how we hold our little conductivity tester in the air, and no lights light up because no electrons are really being passed on, or at least not enough are being passed on in order to turn on the light of the conductivity tester. And there you have it. So everything links back to charge distribution, whether electrons are being transferred, whether they're being shared equally or unequally. That determines sort of whether something has a certain property or not.